After the experiment, Rutherford gives the Rutherford's atomic model. Write down the Rutherford's atomic model. According to Rutherford, the nucleus plays the role of the sun. The nucleus plays the role of the sun, and the electrons revolve around the nucleus. Just like the planets in the solar system. And the electrons revolve around the nucleus just like the planets in the solar system. Again I repeat, according to Rutherford, nucleus plays the role of the sun. This is a nucleus which plays the role of the sun, which is positively charged. I've already said you, Rutherford discovered nucleus. And electrons are revolving around the nucleus in their own path, in the circular path. You can see the circular path. Got it? Electrons are revolving around the nucleus in circular path. Got it? Just like the planets in the solar system. So he said that just like the planets is moving in the solar system around the sun, similarly electrons is moving around the nucleus. Alright? So he compared his atomic model to the planetary motion of the sun. We can say that. Alright? He compared his atomic model to the planetary motion of the sun. He compared his atomic model. Alright? Clear now? So he said that why electrons is not merging into the nucleus, because nucleus is positively charged. So definitely the nucleus is pulling the electrons towards itself, which is negatively charged. So definitely electrons should merge into the nucleus. The answer given by him was that just like the planets is not falling into the sun. Is a planet which is moving in its orbit is falling into the sun? No. Why? Because it is guided by centripetal force and centrifugal force. So Rutherford said the same thing, that the centripetal force which is applied by the electrons over this nucleus is not allowing the electrons to fall into the nucleus. The centripetal force, the presence of the centripetal force which is present, alright, in the planets and the sun, we can say that centripetal and the centrifugal force which balances each other, due to which the planets which is moving in their own path, which is moving in their own orbit, and they don't fall into the sun. Similarly here also the same thing it happens, which is given by Rutherford. So hence according to Rutherford, an atom has got two parts. Alright, an atom has got two parts. One is the nucleus, which consists of the neutrons and the protons. Now of course the neutrons has been discovered, for that reason he gave the name nucleus. And the electrons is moving around the nucleus in the extranuclear part, in the circular path. We can say the electrons are moving. Understood what I said? According to Rutherford, we are having the nucleus which is positively charged with the densest, what you can say the nucleus is, and it's very small in size. Already I said you, the size of the nucleus is 10 to the power minus 13 centimeter compared to that of an atom which is 10 to the power minus 8 centimeter. And just now I said you, when the size of the nucleus was asked to Rutherford gave a very interesting answer. He said that the nucleus is nothing but a cricket ball and the atom is like a cricket field which is a 5-kilometer radius. So anywhere you keep the cricket ball in that particular 5-kilometer radius cricket field, you cannot find it out. Why? Because the cricket ball is very small compared to that 5-kilometer radius cricket field. Here also same thing. The nucleus is very minute, it is very dense, because the entire mass of the nucleus is concentrated here. Entire mass of the nucleus, he said it. And the electrons are moving around the nucleus in circular path, and this one he said as the extranuclear part. In circular path the electron is moving, and it is managed by the centripetal force, due to which it is balances by the centripetal force, due to which it is not falling into the nucleus. Alright, the electrons is not being what you can say attracted by the nucleus, and it's not falling into the nucleus. Alright, it's not merging into the nucleus. We can say that. Clear now? So this was basically the picture given by Rutherford. We can say. Fine. Now we will come to the drawbacks of the Rutherford's atomic model. Alright? Because I said you Thomson's student was Rutherford and Rutherford's student was Niels Bohr. So before going to the Niels Bohr's atomic model, Rutherford's atomic model was challenged by Maxwell. Listen carefully. Maxwell says that any charged particle moving in a circular path, any charged particle, when it is moving in a circular path, it is liable to release energy. Got it? It's liable to release energy because what you find is that this is a nucleus, isn't it? The electrons is moving in the circular path. In this way, the electron is moving in a circular path. Clear? The electron is moving. This is the electron which is moving in a circular path. So, what he said, that when this electrons is moving in a circular path, because circular path is not made up of cement and bricks. It's not a concrete path. What is that? It's an energy level. So Maxwell said, correctly said that, see, when an electron is moving, when any object is moving in a circular path, object means not neutral, charged particle, remember that, charged particle, I'm not talking about neutral particle, because he said that, what Rutherford said, he said that electrons plays the role of the planets and the nucleus plays the role of the sun, we can say that. He said that we cannot compare it, those particular one. Why? Because sun, planets, they are the macroscopic object and they are neutral in nature. But nucleus, electrons, they are microscopic object, minute objects, and they are charged. They are not neutral. So we cannot compare it, first of all. No comparison is there. Understood now? They are macroscopic and they are neutral. Sun, moon, earth and all these things, planets and the sun. But here the electron is a charged particle and the nucleus is a charged one. And it is microscopic in nature. So there is no comparison, first of all. We cannot compare it the way which has been said by Rutherford. The definition which was given by Rutherford about his atomic model. We cannot do so. Why? He gave the reason behind it. That is the reason I am saying you. That if a charged particle is moving in a circular path, if it is moving in a circular path, it is liable to release energy. Because you will study this in higher class, that when a charged particle is moving, let us say this is a path and this is a charged particle is there. When it is moving, for each and every moment, there is a change in angular velocity. There is a change in angular velocity. One velocity is a linear velocity, another is an angular velocity. Because the angle is changing every moment, the angle is changing. There is a change in angular velocity. Due to change in angular velocity, what you find is that there is a change in energy, because angular velocity is related to energy. Like you are having a kinetic energy half mv square, that is a linear velocity. Here same thing, we are also having the angular velocity, which will give you the energy. Now what you find is that as the angular velocity is changing means it is decreasing. Why is decreasing? Because when an electron, when a charged particle is moving in a circular path, it is losing its energy. It is losing. Every moment it's losing its energy, because every moment the direction is changing, its velocity is decreasing. Velocity is not increasing, it is decreasing. And due to which, what happens is that it loses energy. And due to this loss in energy, I said you already, this path is made up of energy. Got it? So as the energy is being lost, the path gets shortened and shortened, shortened and shortened. It becomes smaller and smaller. As you can see, I have drawn it here. It becomes smaller and smaller. See, electrons is moving. The path gets shorter and shorter, shorter and shorter. So ultimately, it comes closer to the nucleus. Got it? Ultimately, it comes closer to the nucleus, and hence it will fall into the nucleus if an electron is moving in a circular path as it was suggested by Rutherford. Got it? It will fall into the nucleus and it will get destroyed. To happen this, now I told you a long time to you, but to happen this, for an electron, the time taken, which was calculated by Maxwell to be as 10 to the power minus 8 second, it takes for one electron to fall into the nucleus and it get destroyed. It takes 10 to the power minus 8 second. Maxwell also added that, suppose let us compare what Rutherford said is correct, that electrons plays the role of the planet and this nucleus plays the role of the sun. That means let us consider that whatever the electrons is present in our planet Earth, alright, whatever the electrons is being present in our planet Earth, some trillions of electrons are being present in our planet Earth. So these electrons is also moving the same way. So it may happen that the electron will fall into the nucleus as it was suggested by Maxwell. It will fall into the nucleus and get destroyed. So if one electron is taking 10 to the power minus 8 second, it will take few hours for the Earth to get destroyed, because it will fall into the sun, it will get destroyed. Understood? Clear? Maxwell said that. Suppose let us consider that what Rutherford said is correct. So Earth is consisting of electrons or not? Are you knowing it or not? The Earth consists of charged particles. Electrons is consist of. So electrons is moving in the same way. Got it? Electrons is moving. Just like the planets in the solar system, we said, no, the electrons are moving. So when this Earth is consist of this particular charged particle, that is electrons, which is moving. So this is also moving around the sun. Electrons is moving, the Earth is moving, the electrons are moving. So hence what will happen is that as he calculated and said to destroy one electron 10 to the power minus 8 seconds are there. So earth consists of some trillions of electrons are there. If you calculate, the time taken is few hours for the earth to fall into the sun and get destroyed. Did earth destroy? Now he told this one in some 16th or 17th century. Alright, still today we are there. That means what it was suggested by Rutherford is not correct. It was wrong, which was suggested by Rutherford, that electrons is moving in a circular path, because any charged particle, if it is moving in a circular path, then it is liable to release energy, to lose energy, and ultimately it will fall into the nucleus and get destroyed. Alright, so hence he said that we cannot compare the atomic model suggested by Rutherford to the planetary motion. We cannot compare it. It is not at all comparable. Microscopic neutral particle, but here this is microscopic and charged particles. It is not comparable. He said also that if at all we compare, then the earth will get destroyed. Suppose we consider the earth is a charged particle, so it consists of electrons, and hence electrons is moving around the nucleus, around the sun. So it will take few hours for the earth to get destroyed. So it is not possible, because it was said in some 16th or 17th century. In the late 16th or the beginning of 17th century it was being said. So it is not possible. So still today we are living, isn't it? So hence it was being discarded entirely by Maxwell. Alright, so this was the drawback of the Rutherford's atomic models. Ultimately what we can conclude, Rutherford could not also say anything about the stability of an atom. Ultimately could not say, but one credit goes to Rutherford for the discovery of nucleus. That is a credit which goes to Rutherford, that an atom consists of positively charged particle nucleus which is having very high density, because the entire mass of an atom is concentrated inside the nucleus, which consists of neutrons and protons. Because electrons is moving in a path, got it? Of course it is moving in a path, electrons is moving clear in circular path as you suggested by Rutherford, got it? Clear. And electrons, what you find is that as it is moving in a circular path, and the charge mass of the electrons is quite negligible compared to that of the neutrons and protons. Understood the Rutherford's atomic model and the drawbacks also? Thank you very much.